Right. Advent of Code Day 4. Oops, there's my mic. Let's see. How about the sound? Advent of Code Day 4. Oops, there's my mic. Alright. That's good. Okay, so MKDeer 04. Everything in Haskell because I like Haskell. 04 v main.hs. This this, and then GHC this. Alright, it works. Let's read the thing. Ceres series search. Looks like the chief is not here next. One of the historians one of the historian pulls out a device and pushes the only button on it. After a brief flash, you recognize the interior of the series monitoring station. As the search for the chief continues, a small elf who lives on the station tugs on your shirt. She'd like to know if you could help her with her word search, your puzzle input. She only has to find one word, Christmas. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. It's a little unusual though, as you don't merely need to find one instead of Christmas, you need to find all of them. I never understood why people use Xmas instead of Christmas. Like, this is weird. But you need to find all of them. Here is a few ways Xmas might appear where irrelevant characters have been replaced with dot. Okay. This one I don't get. Where does this guy come in? Where does this guy come in? You need to find all of them. As you don't nearly need to find one instant of Christmas, you need to find all of them. Here are a few ways. The actual word search will be full of letters instead. Sure, why not? In this word search, Christmas occurs in a total of 18 times. Here is the same word search again, but where letters not involved in any Xmas have been replaced with dot. Sure. Take a look at the little elf's word search. How many times does Xmas appear? So this is the input. This is the example. Let's put it in example. I guess this is one small example. Let's start with this one. Okay. This word search, you don't merely need to find one instant of Christmas, you need to find all of them. Here are a few examples. Xmas might appear where irrelevant character has been replaced. Yeah, I don't get how this guy, is it like there, then this guy? Like it goes once in diagonal, then the rest is here? This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping. Other words. Sure, that seems fine. This is a little unusual though, as you don't merely need to find one instance of Christmas, you need to find all of them. Yeah, I really do not understand this. What is this? Take a look at all of them. How many extras appears? Or is it just an example where I need to ignore those on purpose and just search for like 1, 2, 3, just 3? Sure, let's start this way and see where it leads, I guess. So do content is read file example like so. Whoops. Print content GHC this. Okay. Then is there like oops, that's chat. Can you go there? That's me. Can you go there? Yes. Is there in Google? Is there a transpose by any chance? Ah, nice. That will be helpful. So I already I think I will need this import data list transpose this. So let's do let grid is equal to lines content like so, and then we can say grid. That seems fine. Then we need to let's say grid t is gonna be transpose of grid. So grid t will be something like does this work? I think it does. Yeah. So we'll have this. Next, I need to let's say count word in count word. Let's say it will take a string and it will return the number of times we encountered the word we want. So count word. Let's say it will take a character and the rest. Let's say like this, and rest. Where W is well, no, it's not word. It's like S. Yeah, where S is the string, and we split it in advance. If we then we are gonna have a thing where we say if is there a starts with? There is data list. Oh fuck! It's in the split package. Why does everything I need is in the split package? This is annoying. I should try to install it after data list utils. Yeah, that's something else as well. Is there like Haskell check if list starts with other list? Is prefix of. Ah, yeah, right. I used this on the previous day. My memory is garbage. Is prefix of. Yeah, okay. Let's just do that. Is prefix of. So if x mass, no, yeah, x mass is prefix of s, we return 1 plus count word on rest. Like so, I think we can probably ignore this. I'm not sure. If reverse this. So I guess reverse is reverse. Yeah, that is indeed reverse, like so. yeah, we can do the same thing. Okay. And otherwise, it's gonna be equal to this, but we run it on something else. Yeah, sure. That's also fine. I guess I could just reverse the string first, but let's not worry about that for now. Let's say count. Let's quickly do a sanity check to see if it works, like x mass. Oops. Like so. Non-exhaustive pattern. Huh. On function count words. Oh yeah, count words. Guess I could put the special case of empty here. Like so. So there is one. If I do a bunch of random stuff, there is one. If I do SIMX, so I reverse it, there is two. If here I have an overlapping one where it's like X mass, like so. Did he say if they could be overlapping? I think he did. Yeah, I think he did. Anyway. And so now I just need to do like map count words on grids, like so. Seems fine. Can I do like I could do a count word grid where I have a list of string instead, and now I turn an int, and count word grid is just g where it is equal to map count words on g, and we do plus the same thing but on transpose g, like so. So I don't think I need this. So it will be just count word grid, like so, and grid will be just lines content. Does this kind of work? Maybe I just need to have a plus here, a parenthesis around those. So is it? Oh yeah, and of course I have to take the sum of all of this. Right. Guess I could do sum this and sum this. Not the cleanest, but whatever. In this case, there is only 3 instances of Christmas, which is correct, I think. This is 1, this is 2, this is 3. That's good. And so if I take this, so this will be example 2. If I run it on this, there is only 8, but in actuality, there is 18 times. Oh yeah, I forgot the diagonal thing. Oh, okay. So there is here there is a fourth one here, like so. Is there another one? So instead of 3, I should have 4. And is there another diagonal one? I think that's about it. Yeah. 1, 2, 3, 4. Okay. Let's go back to the simple example. So let's also I don't know why fish does this. MV example to example 1, like so. To order them a bit better. So let's rerun this. So this is 3, and now I need to check on the diagonals. How do I do the diagonals? So is this? Yeah, it's correct. So I need a new one. I need to generate a grid that shifts every row. Um, hmm. How do I do this? Also, this is not very efficient to generate. Like my thought process is if I can like shift all this by 1, shift all this by 2, shift all this by 3, shift all this by 4, then I end up with some kind of triangle matrix or grid. And then I can just run whatever I'm running right now on it and it will work. So that could be nice. I guess I could just run a drop like drop 1, drop 2, drop 3, and so on. Can I do something like let's keep this one. Let's do let grid is equal to lines content. That's fine. So this is my grid, and now I want to is there like some kind of map with index, map enumerate or something? A Haskell map with array index. Index of elements, map with index, data sequence. Huh. A generalization of fmap, map with index, takes a mapping function that also depends on the element's index and applies it to every element in the sequence. Okay, so we can try that. Import data sequence map with index, like so. Then I do map with index, which will take a lambda, which will be I and row, like so. And there is no comma. I always forget this. And then this will be drop I on row. Couldn't match expected type. What's a sequence? Doesn't general purpose instances? Isn't there? Couldn't match expected type data sequence internal sec with actual type string. What if I import all of it? Do I just need some kind of... No. Do I just need sec? No. Hmm. Haskell map with index. Is there an example of this? Is there an example of this? So S map with index, check prefix, local type, int, local type, local type. Why does it return two local types? That makes no sense whatsoever. Act? What the fuck is act? Maybe I should zoom a little. Prefix rule. Map with index, check prefix. So check prefix x's. Huh. Maybe there is simpler. Maybe there is simpler. Is there like a Haskell enumerate? The enumerate version of Haskell. So, oh, yes. Yeah, okay. So, I can just do map where I have this and this. And I just do zip 0, this with grid. And then I basically have what I want. And I do drop IR. Oh. Boom, 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 boom. Yeah. And so in this case, I think it will work because there is an X here on the third position, there is an F on the third position, there is an A, then there is an S, and that's all good. And if I transpose that, does it also does the anti-diagonal, like the diagonal in the other direction? I think I should check that. So where f is equal to sum et map count word. I do this and then I do let's get t is equal to this. Ah, but that's only shifted by one each time. That's actually good enough, yeah. Then grid d is equal to this. And grid AD for anti-diagonal is going to be equal to the transpose of grid D, like so. And then here we can return f on grid T plus f on grid D plus f on grid AD, like so. I called it F because lack of inspiration. Parsing error on input F. I need the N in this case, I think. Couldn't match expected type char int with actual type int. Yeah, and this takes x's. Variable not in scope, grids. Yeah, this is just G. Okay, what if I do this? This is still 3, fuck. And so if I ignore this implementation and I just run no, if I just run, let's go back to what I had before. So just this, whoops, just this. Let's remember this. this, and what if I do count grid thing on the diagonal I just generated? There is 2. Already it's weird that there is 2. So can I let diag equal to this? Diag and prints diag like so. So this is my thing. Oh yeah, okay. It's also going to keep those, which is quite annoying. So maybe it should be only on the transpose. Like if I do transpose. Mm-hmm. Maybe not. How do I do this? Haskell goes through matrix diagonal. What's the best way to extract a diagonal from a matrix? Yeah, I guess my thing wasn't. I guess I could do my like the same approach, but huh? Only get one element. Zip with this. I think using indexing is okay. So this is just gonna... Yeah, but this is gonna get the main diagonal. I want like all the diagonals. So already this zip width is kind of nice. So the main diagonal is this. You can specify your original definition too. Array-based representation. Yeah, sure. Efficiency, I don't care about efficiency for now. I mean, I can probably modify it, the zip width thing. So can I delete all this and then print zip with the index operator on grid and just an infinite list starting from 0. This is the main diagonal. Yeah, that does make sense. Then I want so what if I just start it at like 1? What if I start it at 2? Oh, already. Oh, can Can I kind of do this, except like, so this is, this will be something. So this will be the row, this will be I. Then by default it's this. So right now, this is what it is. No. Good match, typechar. Isn't just the same thing? Oh, right. No need for that, no need for that. Well, no, wait, there is a need for that. Is that it? Oh yeah, okay. Sure, it's not a tuple, whatever. Next, can I do like if length r, if I is lower than length r, then we get the index. Otherwise, yeah, I know there is probably a better way to do this with maybes and stuff, but for now, let's do just, I don't know, just a dot. If that sounds fine. Can do this, so this is the same thing in this case. If I go back to the invalid index, now we get the xmass. That's nice. And if I have 3, there it is. If I have 4, I have this. That's good. So this is gonna get me, I think all the diagonals. What if I start with -1? Negative index. If I is greater than 0 and this, greater or equal to 0. Yeah, I think I can get all the other diagonals this way. So wait, so 0 was this one, and now -1 should be dot AA dot, which was the case. So -1, no, not this, this. Okay, there is an extra dot because there is like an invalid index, whatever. But okay, it does work. Okay, so let's just do that. Like this will be like there go null, which will take a list of strings and return just a string. And this will be there go null. Yeah, I need an index. Whatever, let's call it D. And let's do this kind of thing, where this will be D. And so now diagonals with an S will be, will again take a string and return this time a list of diagonals. Again, hello from Russia. Hello, my Russian friend, my Gen2 friend. Diagonals will take the grid, and it will just be, I forgot how do you do list comprehensions in Haskell. I think it's just diagonal. I forgot. Haskell list comprehension. I also forgot how they call them. Is it just called list comprehensions? So you have the thing to map, you have the assignment, and you have where it comes from. Okay, so can I just do diagonals D, and D is from minus length, yeah, no, minus length G till length g. Does that make sense? Then I can remove this thing and then say diagonals on G. And let's see. Variable not in scope, so yeah, this is grid, my bad. And this is G here. Variable not in scope, G. So yeah, indeed, this shall be an index. Then the grid. And this should be also, the grid shall be passed to this as well. Does this make sense? I think it does. We get all the diagonals here. That's kind of cool. And I guess now if I just transpose it, I get the entire diagonals. So let's try this right now. Transpose. Oh, maybe I don't. Maybe, oh yeah, no, not transpose, it's map reverse. Reverse. I think I should get all the anti-diagonals now. And let's just try, like with one, like the main one. You're solving the part 1 or the part 2? This is part 1. Let's try, so here this should be the anti-diagonal, the main one, so it should be this, so it should be dot x dot ax. Oh yeah, it works. Okay, I see. So diagonals is good, although it's not pretty, but it works. It's not pretty, but it works. Sorry. Okay. Okay. And so I guess this can be in a where, like so, like so. I will refactor this later. This should all work. Nice. Greetings from Brazil. Brazil. See. Oh wait, no, that's Ronaldo is from Portugal. My bad. How? Okay, no, so that's all the diagonals, all the anti-diagonals. That's good. Okay, so so. Can I just do like my count word on this now? So this should be like so I can uncomment this. Hello, you don't know me. Long time no see indeed. So if the transpose and the diagonal was not right, this was diagonals G, like so, and this will be diagonals on map reverse G, like so, and this should be better. Does this compile? No. Yeah, right. There's an N. Actually, the N can come just here, so that makes a bit more sense. And I would just like to print this too. Fuck. Oh yeah, it's forgot the FG. Now it's 4. Okay, that's good. Let's try with example 2. It should be 18 if I remember correctly. It's 18. Hell yeah. So let's fetch the puzzle input for day 4. Like so, let's do inputs, and does it take forever? No, it doesn't. Nice random numbers. No, it's not random numbers, it's like the number of time xmass is in the grid. And so I have to do it horizontally, vertically, in diagonal, anti-diagonal. You can have superposing, overlapping words, and so on. Okay, this is 18 times. Sure. Let's just try this number that I got. See if it's the correct answer. Yay, it's the right answer. Let's go. Okay. I won't clean the thing right now, so this just works. I can remove this. This is horrendous. I will change it. This is also horrendous. This is kind of fine, but I should find a better name for f. Yeah, sure. I'm gonna put the diagonals thing below. Up, up, up. So, part 2. The elf looks quizzically, what the fuck, quizzically, I guess, like a quiz, so like a question. At you, did you misunderstand the assignment? Looking for the instructions, you flip over the word puzzle, the word search to find that this isn't actually an Xmas puzzle, this is an X dash mass puzzle in which you're supposed to find two mass in the shape of an X. Fuck me. Okay, one way to achieve that is like this. Okay, irrelevant characters have again been replaced with dot in the above diagram within the X. Each mass can be written forward and backwards. Okay, sure. I think the main problem of sport programming on Haskell is it's almost impossible dynamic programming. No, there is a memoiz Haskell memoiz. I think like dynamic programming is related to memoization, where you remember previous states, and it's actually well, it's like you can kind of use like lazy evaluation to do your memoization, but it's a bit tricky. But I know you can do it. I forgot how, but I remember you can just have like this kind of thing, and it will remember your previous input. But I have to look at it again. But yeah, it's definitely possible. I should just give it a try again. Hello, hello, hello there. We are at part 2, and this is the code so far. I'm assuming you already did the thing. Yeah, this is a bit trash, but I'll fix it later. So now I need to find all the cross that are mass. Mass can be written forward and or backwards. Doesn't sound too bad. I only did part 1 and only in Python. You did in Python? In Python? How are you a Haskell expert in writing Python? No, I'm joking. It's true that every time you have a grid, it's a bit... Haskell becomes slightly annoying. But actually it wasn't too bad this time. Like the diagonal thing was a bit of a pain, but besides that, not too bad. Here's the same example from before, but this time all the X masses have been kept instead. Okay, in this example appear 9 times. Let's just copy this very small example. Oops. This in example 3. So let's do example 3 like so. And I think this will just be results 1 is equal to this. And I think I'm gonna have to do something entirely different for part 2. Or entirely, maybe not. but yeah, I don't think generalizing this kind of thing is worth it. So let's just do some space. What is Vata Linux? You mean my nick? Ah. I spent 2 hours debugging the Haskell solution and I had too many off by 1 errors everywhere. Oh. Yeah. You mean for the diagonals or something else? Because yeah, for me I just said like if the index is invalid, just put some random character in it. And yeah, that's it. But maybe you mean something entirely different. Yeah, for the diagonals, yeah. Well, I don't know, my solution isn't pretty, but it works for now. I'll clean it up after. Boom, 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 boom. So, let's do like a count. No. How can I scan? So I would like to like have a like 3 by 3 grid and slide it over the main grid. How can I do that? So I could have like a row offset and a column offset and just increment those. So count cross mass. Yeah, count crosses. Sure. Which will take the grid, which is this, and return an int. Count crosses. Now, what do I do? What do I do? What do I do? So I think I will have like a inner thing where it starts at 0, it starts at 0, like so. Where inner is offset a row, offset column. Ah, Vadim. Very. What's the Russian name? Inner offset row, offset column. And now. Well. I guess maybe this is a bit silly. Can I do like row and rest? Let's try it this way first. And yeah, no. No. How do I get a thing? Can I like take tree of G? And it will be like drop offset row of G, like so. So now we will have like the 3 rows each time. And can I just try that? Can I just try this? No. Print count crosses in grid. Could much expected thing. So this is correct, but also I have a very simple example. Let's copy paste this guy. This will be 4. Let's try it on 4. See if I can. So this will be the 3 first rows. Yeah. And now I need to basically do some kind of map, something on this, and this will be very similar, like take tree And like this will be like or something. Take 3, drop, offset, call on R. Or it won't be that. Possibly incorrect indentation or mismatched brackets. It needs to be after the name of the function. Okay, so this is correct. Yes, yes, yes. Okay, that's good. Is correct cross? How do I check if it's correct cross? Well, I think I should say like cross, which will be just the tiny grid, and I can just have like well, could I just like literally make? I mean, I could reuse the diagonal thing. Well, actually, let's do that. Why not? Let's do diagonal this. Let's do this. Yeah. And you can for an M then check the matrix offset. Yeah, indeed. But I already have my little diagonal function here, so you know, might as well reuse it. And so let me just quickly type it as well. And this will just return one string. And this should be like diagonal 0 of cross is, how do we do this? Is equal to mass. Well, can do this. Or this. Well, whatever. Let's just do SM, this. And let's do... this is not gonna be pretty, but map reverse this. Okay. Yeah, it looks nice. You were hiding it though. True. Well, the diagonal is fine. I mean, it's a bit ugly, but oh well. And maybe for context, I should... Oh. How did this even compile? I put the wrong type in there. Huh. Maybe I didn't save it. Oh yeah, right, I just didn't test it. So this is actually an int thing. And so can I just very quickly make that in the global scope? Put that in the global scope, and then is correct cross on grid. And let's use example 3, which is the already pre-made thing. This is true. And if I put 4, this should return false, which makes sense. Okay, it seems to be working. I can reindent this. I will have to fix this later, but whatever. For now, not necessary. Okay, so now I have my shifting thing. So I can, I can do is let's cross is equal to this. So this is my cross in something, and I can do count crosses is actually an integer. So is there a way to whatever? Let's just do if is correct cross Why don't you configure formally and HLS? They help with the parser. Yeah, I already have the Haskell language server thing, and I mean, it runs and so on. But it only works if I have like a full project with like the cabal files and so on. And I just didn't have the time to set it up properly for like a single file application. Boom, 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 boom. So if it's a correct cross, then 1, else 0, and I apologize for that kind of thing in advance. And then I do just plus inner, it's gonna be offset row plus 1. Hmm. Offset row plus 1. Actually, can't I just generate all the offsets first? Like have from 0 to length minus 3. And I just do the combination of all those. So couldn't I do like let's say OR for well that's OR like off R of C, and this would be of R, which would come from 0 to length G, and I forgot if you have a comma, and of C would come from 0 and length head G, like so. Head G. And that would be all my offsets, I think. Can I actually just quickly try that in GHCI? So let's say I have a x's, which is like this, and this, and then I copy paste this, except G is x's. And I think that is correct. Yeah, okay, that should be my offsets. So can I do like let offsets is equal to this? Well, okay, that doesn't look pretty, but oh well. Oh well, can I cut this slightly? Kinda. And then I just do well, actually, why do I do this? Let's just well, I'm getting lost. Where am I? This? Sure. Whatever, let's remove this. I have my offset, I can just do inner like this. Okay. Okay. Something like this. And then I just sum them up. Oh, and actually, inner. I'm getting a bit confused, but this is gonna be is correct cross this. So this is actually what inner does. Alright, this is ugly. Okay, I'm a new line let kind of person. I also add a new line after the where. Oh, you mean like this? Huh. Yeah, I guess for long inner function, I would do that. For small ones, I would keep it this way. But yeah, I guess it's not, at this point it's just like taste. So inner this, and now I just have a list of true or false, and I can just do filter. Isn't there already a filter option like Haskell list comprehension filter? This. What? Okay, this is something else. Oh, okay, you can put predicates there. Yeah, but that's for like the iteration, that's not for like the result. Whatever. Can I do ID just like so? And length this. No, not you. This 9. I don't think that's correct. But at least it counted. Oh, 9 times! Perfect. This is awesome. Let's see if my disgusting piece of shit code works on the input. It was rather fast as well, but I'm guessing the input is not that big. Let's see. Fuck, that's not the right answer. What do I do now? What do I do now? And so this one was correct. Cat example 4. Yeah. And so this is supposed to appear 9 times. Where's my thing? And it does appear 9 times. Where could I have missed something? Where could I have missed something? And just as a sanity check, let's check back on the example 3. Yeah, it's 1. You can copy the first 3 lines of the actual input and use them as example input. Or any random 3 to 5 lines. Yeah, you're right. I could do that indeed. Just wanted to quickly take a look at the code, see if I'm missing anything. Just to make sure. Inner, offset row, offset call. And maybe reread the thing. So it's an X mass puzzle in which you're supposed to find the 2 mass in the shape of an X. One way to achieve that is like this. Irrelevant characters again have been replaced with dot in the above diagram. Within the X, each mass can be written forward or backwards. Okay. Here's an example from before, but this time all the X masses have been kept instead. Oh, I'm trying with the dots thing. Maybe what? So the dot thing is actually all that don't belong to it, but I haven't tried on the this thing, which is example 2, I think let's try example 2 first. See that when there is multiple other things. Ah, it's 16 this time. Okay. Okay, but I think it's the same. Wait. Cat example 2, cat example 4. This is the same, right? So M A M A S M. Okay. So with the 4, and it's strange that I don't have like more of them. Like with the 4, I have 9, and with the 2, I have 16. Oh no, I do have more of them. Okay, okay. So I have too many. I have too many of them. So what happens? What happens? What happens? Oh, yeah, it's just my conditionals here that are garbage, I think. So it's because it's like an and. Like if there is only one diagonal here, I say it's a cross. How do I do this? It's like if the first diagonal, so let's just do let main diagonal is equal to this. And let's do this, oops, main and tie diagonal is going to be the same, except I do this like so. In and maybe here indeed I would like to have this kind of thing up. So now I just need to make sure that it's like if main diagonal is equal to mass or sum, and so, and here it's and no, it's like and yeah, okay, okay, and anti-diagonal, anti-diagonal. Okay, will this work? 9, okay. And if I take back my 4, still 9, okay. Okay, let's run it on inputs. I have a lower number, which makes sense. Straight. It's the right answer. Let's go. Okay. Okay, okay, okay. Alright. Feels good. I think I will spend a bit of time cleaning up this mess. So first let's do my result thing. So printf part 1 is this. Result 1. Part 2 is this. Part 2. Import text. Printf. Printf. Like so. Okay. Okay, and I think that's still correct, right? Yeah. And yes, okay. So we have to refactor so that those values don't change at all. Alright. Not sure how to do this. Not sure how to do this. Already here, can I drop the R somehow? Like, can I do this, and like combine those two? Okay, I can indeed do that. Is the dot operator like has priority? It does, crazy. Okay, that makes it slightly easier. Um, do-do-do-doom. Here, I think I can shorten this a little. No. Hmm. Mm-hmm. Nice. You can use the let inside of the comprehension and use the predicates on the left-hand side. And then I just have like, you mean this. Can I use a predicate for this? Like, you mean like this? Or like, maybe I should start aligning my things. So, let's do it the Haskell way, where this comes here, and this would be, can I do a let here? Like, valid is equal to this. Can I do this? Maybe I don't understand. That does not work. How much years do people in England study English? In Russia, we learn 11 years. I'm not from England, but and a lot of people still make mistakes. Let valid equal thing. Yeah, but that's a bit pointless, no? Like, let valid equal this. And then what? Like, valid? I'm confused on how to have the predicate thing. And then valid equals true. Yeah, but like that's the same thing as this, and this is the same thing as this, right? Or am I completely insane? But I mean, I guess I can try, but yeah, it's the same thing. Also, oops. We end up going for this, I should put like the unit thing. How? Yeah, I'm very wrong, sorry. That's the first time you're very wrong, though. So, it's okay. All is forgiven. Why doesn't this work, though? Maybe I should go back in GHCI, where I have my thing of x's, then I have this. And so, yeah, this does what I expect. And then let's say, so to understand, can I do like if of or is equal to of C. Right. Oops. This is this. This is this. This is this. Okay, so that does make sense. Why doesn't it work though? Huh. That's strange. That's peculiar. Can I copy paste this and then go back to what I had? Like copy paste it above, like so. Oh wait. Like so. So let's go step by step. Oh, this already doesn't work. Fuck. What did I do? What did I change? I changed nothing. Hmm. What? Oh, is that that? Oh, it literally needs the parentheses. Oh, okay. It's the first time that no, not the first time, but one of the very rare times where Haskell allows you to do like a logic error. Or like, you know what I mean, like you don't compile it and it doesn't work the first time. So yeah, I guess I'll just quickly redo what I just did. So empty this. This will be this with this. This will be here. This will be here. This will be here, and this will be here, like so. This can go away, and that's it. Yeah, okay, that still works. Nice. Nice. Next, next. I guess I could just have those same way I have them above. It's probably fine. Okay. Is correct cross. The is correct cross is probably fine in my opinion. Yeah, I think it's okay. Like there is no point in doing a map or anything. Yeah. All right. Yeah, I think this is fine by me. Next, the part one. The part one. This is probably fine, although I could call this a better thing, like whatever. Count word. Can I have my own count word? Count. Like whatever. Let's call it count. Count. Up, up, up. And this is not axis, this is grid. Or G. Yeah. So yeah, that's fine, I think. The diagonals thing. This part, I think is fine. Count occurrences. Oh yeah, sure. Ah, but I have 4 times the count. It's gonna be too big after. It will stay count. I don't want to put this on multiple lines. Then, yeah, that's pointless. The diagonals, like plural, is fine. The diagonal single is, I would like to change it a little. Is there a way, I know there is that in Rust, where you have a boolean and you convert it to a maybe. I think maybe probably in data, maybe, no? Data, maybe. Data, maybe. Can I take a bool? Is just, is nothing. Null. No. Haskell, boolean to maybe. Yeah, maybe that's pointless. I think the function maybe can help. There's a function maybe? Maybe. Oh, okay. Yeah, I guess I could just use that on ID. But it takes a function to, not a bool. Yeah. How do I want to do this? So the zip width will stay, but this needs to be slightly different. Is there like a... Oh yeah, but even better, is there a way to index a list and instead of having an error on an invalid index, it returns a maybe. That would be... Oops, that's me. Hello there. Yeah, I don't like it. I know it's fine, but I don't know, it annoys me to have a lambda. I would like to have this. Let's say this was the operator to like get a maybe if out of a list I could do zip with what could I do? Like this with my imaginary operator. Could do this, and then I could just do map, map. Or I could do like flatten. How do you do again if you have a list of monads and you concat them? Passe une bonne fin de soirée. À toi aussi. Concat something. It's not concat, is it join? I forgot. GHCI. Join. Control monad. System control monad. Yes. No, it's not that. Sequence, yes! Oh, I remember using that in another project. Sequence. So M is a monad. It's a traversable, so a list of monads, and then it returns a monad of a list. Yes, kinda. So then I could do like sequence on this. And then from maybe this. And I think, what is it? From maybe. I forgot where from maybe is. Takes a default. Oh, the default is the first value? Yeah, that's fine. It's kind of what I want. Kinda. Yeah, this is overkill as fuck, but I don't know, man. It's kind of cool. Haskell index list, but return maybe. Can I get a position using a maybe? Safe index. Yes, that's kind of what I want. Yeah, I know it's a small change. Is it built in somewhere? Oh, there is this. Is this a built-in thing? Yes, data list. See? See, I'm a genius. So it's just this, and it's from data list. And I was complaining about the Haskell operators being weird, but you can't resist using them. It's just too good. It's just too good. And does this kind of work? No, it's not there. No. What do you mean it's not there? Don't break my dreams. List index operator starting from 0 returns nothing if the index is out of bound. This is the total variant of the partial this operator. Warning, this function takes linear time to index. Yeah, sure. Yeah. Yeah. And it works with minus as well. That's perfect. Why doesn't it work? It's in data list. I include it from data list. Is it just my import that is bad? Can I do just... You have kind of too old GHC. I'm on Arch Linux. How do I have an old GHC? I have 9.2. I have 9.2.8. Do they say in which version it is? Somewhere? Anywhere? Where is it? Mine is like 9.10. No! This is so sad. Say it's in base 10. Base something. So, I do Pacman QMS Haskell base. Haskell base compat. How do I see this? Base. Yeah, that's not this. No GHC version though. This might need some cable thing. No! I don't want the cable thing. Whatever. I don't care. I'll copy paste the operator myself if I have to. I don't care. I know it's overkill. Who is gonna stop me, hey? Who is gonna stop me? There we go. Fuck versions. Just copy paste stuff. Where's the from maybe in? From like in from maybe. Is it in data maybe? Okay. Data maybe. From maybe. Sure, there is a way to do this even. Fuck! It doesn't work now. Ah. Why doesn't it work? Well, it does work for the main diagonal. That's good. It does work for the main diagonal. How do I do this? Fuck. I really wanted to use my fancy thing. Ah well, fuck it. Fuck it. Yikes. Let's just do this. Let's just do try index. And where try index I and L. So I guess this is R. Wait, no. First takes R, then I. Oh, sorry. Up, have a call. Up. I was just proposed to do some astrology. Uh, uh, how do I do this? Just do this, and I just put my if somewhere like this. Then if it's this, we can say I. Otherwise, we just say some dummy character. How is that? Oh, he's oh, that's not good. Why not? Why not? Just need to be it needs to be one more. It's weird because like only like this works with like the top level function, but not the nested ones. This seems to still work, if I'm not mistaken. Yes, it's still the correct answer. Yeah, I mean it's slightly more readable, but whatever, it's not great. Well, whatever, try index is good. And the last one I'm happy with. And I think that's about it. I mean, I guess there is nobody fucking watching after this huge break. Oh no, there is. Like, okay. I guess you're doing something else. But yeah. I will just put a small comment. Still here, damn. Can't use the operator equals my base version is too low. Let's just put that somewhere. and oh, actually that could have been epic. Like could I have done like something like this and like from maybe this. Couldn't I have done this? Wait, I'm curious now. Wait, sorry. This. This. Let's do the thing where I copy paste like a crazy person. Yeah, maybe it wouldn't work. So I would have to do like R, I, this, and then do like R, I. No? Couldn't match with actual made type, maybe car. Doesn't from maybe return just an element? Anyway, okay, it's too late, I have to eat. It's too late and I have to eat. The dot is first. Nope. I mean, maybe yeah, but oh yeah, but I need to do still this. Okay, so that works. Do I really want this? Yeah, that's not very clean, but I don't know. It's kind of okay with the comments. Now, can I use control arrows to avoid doing a lambda? Is the question. Do you think? Like, because I basically want to apply those arguments to this function, but there is this in between. Is there some arrow magic that I can use? What was Haskell? Well, why do I do this? Just Google. Just Google it. Up. Split the input between two arguments. So it takes the arguments, but that's like 3 arguments. Isn't there like a thing for only 2? Split the input between the 2 arguments arrows and combine their output. Fan out. Send the input to both arguments. And combine their output. Ah, okay, that I understand a little better. That I understand a little better. So you have 2 computations, and you return a function that takes their argument and it passes the same 2 arguments to the functions, and then returns a tuple of the result. And this is kind of the opposite, where the arguments are different, and it returns a tuple of both. Hmm. Yeah, I don't know. I don't know. This is it's too late. It's too late. I'm not another rabbit hole, please. I would have liked to do this though. GHCI import no data maybe and whatever. Let's say f is equal, like it takes ri and it returns like well, I can just use exclamation mark as an example. So t from maybe, then from maybe this is this, so it takes maybe car and returns car. Okay, then the type of this operator takes a list, an int, and okay. Well, I guess I can't do that, but whatever. Let's say fx is equal to just x, and so the type of x is this, the type of from maybe is this. Oh, right, I need f to be xy is equal to just, let's say, x plus y. Okay, let's do this again. From maybe, this is the type, and the type of f is 2 inputs, and returns a maybe a, so that's kind of what I want. My brain is too tired too. I expect you to stream as late as yesterday, and I'd rest after work before the stream. Sorry, but wait, I think, please, we can figure this out. And so, what if I have like from maybe this, and it takes just f like so? Is this even a thing. No, it's not. No, it is not. Hmm. Fuck. Uh, I'm gonna try a few random shit because I don't even know how to use this, but so it's not that. Takes a maybe car B maybe. Yeah, okay. This is this? No, it's not. Alright. Oh well, I will just say to do. Find a fancy way of moving the lambda. Okay, whatever. And it works, and I can go to sleep. Or no, I can eat. And yeah, I think it's gonna be the end of the stream. Thank you, everyone, for watching, and thank you for the help, as always. This day was kind of fun. I'd ask ChatGPT, to be honest. That's not a bad idea. Fuck, I was about to quit, but now uh, you've put me in a situation. Can I even use Grok, like the X thing? Do you know Haskell? Yes. Keep your answers short. I have the following code. The following code takes R and 7 sure. Can you remove the lambda? Can you fuck? How do I even say this? Can I remove this part? Make it point free. What do you mean point free? This is the full code. Can you remove the lambda without creating an extra function? Oh, make it point. The style where everything is functions and composition is called point-free style. Everything is function and compositions. Functions and compositions. Yeah, maybe I'm too sleepy as well. That's not good. I think it's just doing random shit at this point. Yeah, right? Because what's that? Import data, maybe. So this, and then this with flip this. Or I need to declare f as well. Yeah. Okay, that just doesn't work. Anyway, let's just go back to my little to-do. And yeah, we'll end the stream. Enjoy the evening, everyone, although it's already quite late in the evening here. And yeah, I'm quite hungry. Anyway, see ya. See ya tomorrow, maybe, if I feel like it. And yeah, enjoy. See you.